I'm skipping example 6 for now. I think the inverse trig function probably just makes the concept harder than I need it to be right now. So let's just talk about this one. Remember, we're dealing with these limits at infinity, and we're trying to use some of our algebra tricks to get it there. We know if we have like a number over infinity, what does that always go to? 0. And it doesn't matter if it's over positive or negative infinity, it would go to 0. But sometimes we had to kind of do some reasoning, like we might have to divide everything by the highest power of x, we might have to multiply by conjugates, those kinds of things. Let's take a look at this one. If I want the limit as x approached negative infinity of e to the x. Right, so if I'm dealing with e's, I can't really do a whole lot as far as like algebra tricks. E is just a number, kind of like pi, it's about 2.7 and then just keeps going forever. If you plug that in, e to the negative infinity, what does a negative exponent do? Okay, so that would be 1 over e to the infinity. Alright, so if e is a positive number, when you take it to a bigger power, what is happening to that e? It's getting bigger and bigger, right? So e to the infinity, we know this is just a number 1 divided by a bigger and bigger number. And anytime you have a constant over infinity, what's that go to? 0. Okay, so sometimes we just have to kind of think our way through these. Let's try a couple more where we just have to think about them. All right. I want the limit as x approaches 0 from the left of e to the 1 over x. Okay, could I even just plug in a 0 right here? No, because you can't do 1 over 0. But if I think about my table, if I wanted to plug in things. 0 to the left, I'm putting in something smaller than 0. So it'd be like 1 over negative 0.1. Or if you want to get closer, you'd have to do negative 0.01. Or you could do negative 0.001. All right, grab a calculator. Let's see if we can kind of figure out what's happening to this exponent. What's 1 divided by negative 0.1? What's 1 divided by negative 0.01? What's 1 divided by negative 0.001? Okay. And we know these are negative exponents, so it's really just 1 over this. So what's happening to the denominator on these? The denominator is getting bigger and bigger and bigger, which means this whole thing is going to 0. If I have 1 pizza and I'm inviting more and more and more people to come in and eat it, the amount we're getting is getting smaller and smaller. Does that make sense to everybody? Let's do, if I ask for the limit as we approach infinity of sine x, what's the graph of sine look like? A wave. And we know that just keeps repeating, right? So as I go to infinity, is this going to any number? No, it's just constantly bouncing up and down. It's not getting flatter as time goes on. We know it's just the same thing over and over and over again. So do we have any single number we approach? No, so this one does not exist. I want you guys to take a second and see if you can figure out what these would be. So what do you think? Infinity cubed. What do you think that's going to go to? Yeah, this is just infinity times infinity times infinity. If you just take three really big numbers and multiply them together, what do we get? Even bigger number. So that's just going to infinity. What about b? Negative infinity. You have a really big negative number cubed, so 3 negatives is still negative. Alright, so it is possible to get positive or negative infinity for an answer on these. What if I gave you this one? Alright, we kind of had a situation like this last week. We had one where we had infinity plus infinity, I think. And if we add two really big numbers, we know it's just going to be an even big number. But this time we have infinity squared minus infinity. If you're subtracting two really big numbers, do you necessarily know what you're going to get? No. It's not obvious here what that would give us. In general, if you add big numbers, you get another big number. So we could assume that that's true. Infinity plus infinity would still be infinity. But we can't really do that with subtraction because we don't know how much, infinity squared, how much different is that from infinity? That's really hard to answer. If I'm multiplying two big numbers, infinity times infinity, what do you think that would give you? Infinity, we kind of did that with the x cubed. But if I were dividing them, do we know? No. So in general, if we're adding or multiplying infinities, we can say it's still infinity. But we can't do that with subtraction or division. So is there anything I could do to rewrite this? We take out an x. Then we would have x times x minus 1. Okay, if I plug this in, then we have infinity times infinity minus 1. Alright, if you take 10 million and subtract 1, we still have a really big number, right? So infinity minus 1 is still just a really big number. So here we're just multiplying two really big numbers, so we get a really big number. We're getting very precise here. Big number times a big number is a big number. Yes, and there is no exact number. You could make your teeth chart, and start plugging in huge things, but yeah, it's just big. So could I just plug in my infinities on this one? No, because I would end up with infinity divided by a negative infinity. That really doesn't help me much. Even if I factor, nothing cancels out. What other strategy did we use last week? When we had radicals, we multiplied by a conjugate. And when we had fractions, if you look back, we would divide everything by the highest power of x. What's the highest power of x on this problem? X squared. So if I took everything times 1 over x squared, that gives me 1 minus 1 over x divided by 3 over x squared minus 1 over x. Okay, that is not super helpful. Why? Yeah, we're going to get 0 on the denominator. And can we divide by 0? No. So the reason this one didn't work out nice is because my highest power of x was from the numerator. So if you ever have that and you're getting 0 on the bottom, just back up and do 1 less power of x. Let's try 1 over x, since 1 over x squared was too much. Alright, so if I did that, x squared times 1 over x would give me an x minus 1, 3 over x minus 1. Alright, now can can we figure out what's happening? Infinity minus 1 is still infinity. 3 over infinity minus 1. So we get infinity divided by negative 1. So negative infinity. Our answer. I am actually going to skip the next one, and I want you to try this. It's not really a quiz question because we're not going to have a quiz tomorrow, but why don't you see if you guys can figure this one out? Highest power of x is x cubed here. We have a limit. X approaches infinity. 1 over x cubed is still 1 over x cubed. X squared divided by x cubed, you cancel 2 x's, so you get a 1 over x. 2x cubed divided by x cubed would give us a 2. In the bottom we would have 1 minus 5 over x minus 3 over x squared minus 5 over x cubed. Is everybody okay with that step? So then, anything with an x on the bottom, a number over infinity is going to go to 0. So this is basically 0 plus 0 plus 2 over 1 minus 0 minus 0 minus 0. So you get 2 over 1 or 2. All right, let's look. I know there were some of these on the homework that you guys were trying last week and we kind of had a little bit of trouble with. So if you would grab a book and let's look at one of these problems. All right, so this is one where it gives us some conditions and we have to draw a graph that meets all of those conditions. On these, there's more than one possible graph, and you're probably not going to get it immediately. Like you're going to have to tweak your graph a little bit as you go through. So let's look at our conditions. This one had a bunch. F of 0 equals 3. What does that mean? This is just a point. 0, 3 is just a point on the graph. Okay, then it tells us the limit as we approach 0 from the left of f of x equals 4. So as I'm coming into 0 from this side, it has to equal 4. Now can I put another closed circle here? No, because it's got to be a function, so that means it has to be coming into an open circle. Now I don't know a whole lot yet. For all I know, it could be coming up, it might be coming from below. We might have to go back and tweak that. But I know it's coming into that point. As we approach 0 from the right, it's going to positive 2. So again, I have to come in and tweak it, but all I know is it's going towards 2. That has to be an open circle. So the definite things right now are these 3 circles. The lines themselves, I might have to change. And that tells me the limit as we approach negative infinity is negative infinity. That means as I'm going forever in the negative direction, the graph has to be going to negative infinity. Does mine work? Where is mine going? Positive infinity. So that just means, all right, I know that point was correct. I just have to switch this. gotta be going down as I go forever. All right, next condition, the limit as we approach 4 from the left equals negative infinity. And right below it, it says limit as you approach 4 from the right is positive infinity. What's happening at 4? A vertical asymptote. Okay, so I'm going to have to kind of change my graph. It's not working there. We know 4 would have to have a vertical asymptote. And so as I'm coming in from the left, smaller than 4, it's going to negative infinity. And as I'm coming in from the right, it's going to positive infinity. And I don't really know what else it's doing yet, something like this. I just know that that's going up. And then to finish this piece, let's read the final condition. As we go to infinity, my graph is going to 3. What does that tell me? Horizontal asymptote at 3. As we go forever towards infinity, this graph is approaching 3. So this is a little bit tricky, and we had to tweak our graph as we went. Every time we read a new condition, we had to see, do I need to change something on my graph? What I recommend, do that just how we did. Kind of lightly draw in your graph as you go, change it as you need to. I would suggest at the end reading back through all of your conditions and making sure that all of them are still met and that you didn't accidentally change something that you shouldn't have. All right, any questions there? Okay, so what we are going to do now, I posted a handout on Google Classroom. This is just going to be kind of class notes, but you guys are going to help me through these, so it's just some extra practice on these things. I'd like to take a few minutes. Do you guys want to try some on your own before we're going to go through them? Why don't you get groups of 2 or 3? So kind of group up, talk through some of these problems, and then we'll come back as a class and go over them. Okay? You guys want to check the first couple. So you notice the first 3, they're practically the same question, but what changed?
She's on the whole wrong.
Oh, that would explain it. So you probably were on the epsilon delta one. Oh, okay. So on these, they're all pretty much the same, except one's approaching from the right, the left, and then overall. And we always check, can we just plug it in? No. When can we plug it in? If the bottom doesn't equal 0. But this one does. So then we always tried to factor and cancel out our problem. So the bottom factors into x minus 6, x plus 2. So then what happens? So we get here. Alright, so I put this up here to kind of practice our reasoning skills. Can I plug in my 6 yet? No. So we know we're getting a vertical asymptote at 6. That means vertical asymptote, it's either going to positive infinity or negative infinity, right? If we want to think through that, so we know the bottom is going to 0, but you're putting in things bigger than 6 because we are approaching it from the right. Grab a calculator real quick. So if you put in like 6.1, 6.1 divided by 6 would give you 0.1. So if you do 1 divided by 0.1, you get 10. So if you're getting closer, you put in 0.00 or 0.01. So 6 or 6.01 minus 6 will be 0.01. 1 divided by 0.01 is 100. If we put in 6.001, we get 1 divided by 0.001, which is 1,000. So if you take your one pizza and you are inviting fewer and fewer and fewer people, what's happening to the amount of pizza you get? It's bigger and bigger. A lot of times what I do just as a notation to myself, I tell myself it's going to 0, but it's from the positive side because it's things bigger than 6. So 1 divided by a smaller and smaller positive number is going to infinity. Now on 2, it starts out the exact same problem. So we know it still factors and reduces. And we get to the same point. But now you're putting in things smaller than 6. So what's happening on the bottom? It's getting closer to 0, but they're negative numbers. So 1 divided by a smaller and smaller negative number would take us to negative infinity. And we said at vertical asymptote, you're either approaching positive or negative infinity. So number 3, the overall limit. Remember, for the overall limit to exist, the left and right have to match. One side's going to infinity, one side's going to negative infinity, so the overall limit does not exist. All right, you try to think through a couple. So number 4, can I just plug in 0? No. But if you're approaching from the positive side, does the absolute value change anything if you're putting in positive numbers? No. The absolute value of a positive number is the same as the regular one. And what happens when you divide a number by itself? You're getting 1. So it's just approaching 0 from the right, but it's always 1. And so we get 1 for our answer. Number 5, if you are putting in negative numbers, the absolute value would do the opposite of that on the bottom, right? It would take your negative and make it positive. So it's the opposite of what you put in. So when you take a number and divide by the opposite of that number, we're getting negative 1 every time. So that one is negative 1. Are those two okay? All right, number 6. We can factor, but does anything reduce? No. The top is going to 7. The bottom, you're putting in something bigger than 7, squaring it, and subtracting 49. So what kind of number are we getting on the bottom? It's approaching 0. Is it positive or negative? Positive. Because once you square that x, it's a positive. And it's a little bit bigger than 49. So 7 divided by a smaller and smaller positive number. Positive infinity. Is that okay? Other ways you could have factored the bottom and worked it out that way as well. So number 7, we're approaching 7 overall. So that means I could be putting in something bigger than 7 or something smaller than 7. However, top is going to 7, so we know there's a vertical asymptote at 7. We're just trying to figure out if it's going to positive or negative infinity. You put in something close to 7. You subtract 7 and you square it. Whether it's positive or negative, once you square it, it becomes positive. So we're approaching 0, but from the positive side. So 7 divided by a smaller and smaller positive number. Positive infinity. Now, if that square hadn't have been here, we wouldn't be able to do that limit. Because as you approach from the left, it would have been negative, and from the right, it would have been positive. And it wouldn't have matched. All right, number 8. So I am approaching 3. So we have to think. The top is going to 3 plus 2 is 5. The bottom. If you put in something smaller than 3, you're getting a negative. If you put in something bigger than 3, you're getting a positive. So one side you're getting negative answers, the other side you're getting positive answers. Can we evaluate that? No. So what do we put? All right, number 9. When I throw a square on the bottom now, it's still approaching 0, but whether it's positive or negative, when I square it, it becomes positive. So 5 divided by a smaller and smaller positive number. Last. Okay, so this is a piecewise. Are all of those okay? First page, 1 through 9. So this time we just have to think about which piece we're on. If we are approaching 3 from the left, we are putting in things smaller than 3. So are we on the first or the second piece? Smaller than 3, less than 3, so that's the first one. Can I just plug in my 3? Is it giving, it's not breaking any rules, so it's just 3 squared minus 5. And we get 4. We're approaching from the right. That means we have things bigger than 3. If x is bigger than 3, which piece are we on? So if I plug that in, we get 3 plus 2, which is 5. So the overall limit? Why not? If you graph this piecewise function, there's a break in the graph. We have a discontinuity. Those pieces don't match up, so we cannot do the two-sided limit right there. Any questions? So Friday, I gave you guys the book problems. And I think I told you were ready to work up to a certain point, but you didn't have to. We are now done with this section. So I want you to work on this. It is going to be due on Wednesday. So you will have most, if not all of tomorrow to work on it as well. We'll kind of see. I might do something towards the end. But you've got some time right now, and you will have a good chunk of time tomorrow as well.